soil, the vast biome right beneath our feet. Though it may seem like just, well, dirt, this underlooked ecosystem is a thriving system of essential services, biodiversity, and more. Soil biodiversity refers to the number of living organisms that are right underground, and more than 25% of the world's biodiversity is located in soil, with the most diverse part of soil being 1,000 times smaller than one would think. Microorganisms are abundant in soil and play a crucial role in plant growth. And here's the scoop. This spoonful of soil holds more than 50 billion microorganisms. Now, let's explore a little bit more about that interaction between microorganisms and plants. I introduce the plant microbiome. The plant microbiome consists of groups of microorganisms that live around a plant and provide the plant with needed services, such as nutrients, oxygen, and water. The number and type of microorganism in a plant's microbiome depend on the plant type, plant age, and the surrounding soil. The plant microbiome contains 3 spheres: the phyllosphere, the endosphere, and the rhizosphere. The phyllosphere is located on the leaves and stems of the plant. The endosphere is located inside plant tissue. But the most important part of the plant microbiome is the rhizosphere, which is located in the soil surrounding a plant's root system. The microorganisms in the rhizosphere determine what type of nutrients and how much of each nutrient a plant receives. The microbiome aids in photosynthesis, and the microbiome provides the plants with needed inorganic molecules, such as carbon through the carbon cycle. Essentially, a plant's interaction with its microbiome determines the plant's survival. This mutualistic relationship can help plants survive during natural disasters, such as a drought, or when a plant is struck by disease. But there are threats to the plant microbiome, which leads to threats to our food supply, if those affected plants are needed for human food consumption. Enter salinization. Salinization is the accumulation of salt and ions in soil, which can be toxic for most plants. But how does salinization impact the microbiome, you may be wondering? The microbiome decreases with increased salt levels due to the introduction of toxins and osmotic stress. This loss leaves the plant with a lack of nutrients and needed services that can stunt growth and even cause plant death, threatening ecosystems. When there are threats to the plant microbiome, humans are also threatened, since salinization can impact agricultural land. But not all hope is lost. Currently, research is being done to combat salinization, and one solution takes us right back to where we started, at the microbiome. By inoculating plant roots with a selection of bacteria that can support growth and provide nutrients to plants in a salt-stressed environment is an organic solution that can be implemented around the world to help our microbiome and therefore help our food supply. With more research, more solutions will become available, leading us to a more sustainable future. Thank you for your time.